Pre-calculus students, this is the lesson for section 5.5, which is the law of sines. And I'm just going to cover a little bit today because juniors were taking the ACTs and we have to do a little something here. So we're going to cover the law of sines and how to use that. So our objective here, I will be able to understand and use the law of sines to solve triangles given angle, angle side, or angle side angle. Now, hopefully this brings back some memories. And that's because this is all from geometry when you were talking about congruent triangles. So when you see angle, angle side, that means you have an angle, another angle, and a non-included side. And that's because if it were the included side, the S would get to go in between the two A's, and it would say angle, side, angle. But this one is angle, angle, side, which means the side is not the side that's right between the two angles, so non-included side. The other one, ASA, that's the one where the side is the included angle. So it's all about the order when you read off your triangle. What do you have? Do you have a situation where it's angle, angle, then side in that order? Or is it angle, included side, and angle? So like it says, the law of sines can be used to solve triangles if we have those two situations. So the formulas that we're going to get, remember, you get these formulas for the tests. It's more about you knowing when you get to use them. So law of sines for angle, angle side, or angle side angle. Now, there is another case that's going to take us a lot more work, and that is side, side, angle. And in fact, your geometry book doesn't even teach this one. Geometry books within the last 10, 12 years or so have cut this one out. And that's because, like it says, it is the ambiguous case. And it was always difficult for students to understand at the geometry level, but it really should be written like this. Capital S, lowercase s, and then a capital A. Because side-side angle only works for congruent triangles if the biggest side is opposite the biggest angle. So biggest side has to be opposite the biggest angle. That is the only way that you can use side-side angle. And again, it's one of those things that students would miss in geometry because, you know, at that point you're kind of just trying to get used to the, hey, it's got three angles, it's got three sides, and some students would just miss that. But side-side angle is the biggest side that has to be opposite the biggest angle. And then the other side is just one of the other two sides. So those are the cases where we can use this. And like it says, ambiguous case means, oh, you might be able to, you might not be able to. And we're going to learn some more about checking for that as we go through this section. And then the second star says, apply the law of sines to real world applications. We're going to need a couple days before we can get to that. So, law of sines, very basic, love it. In any triangle ABC with angles A, B, and C, opposite sides, and again, notice uppercase letters for the vertices, the angles, and then lowercase letters for the sides, opposite the sides A, B, and C, respectively, the following equation is true. So to find the angles or the sides, we have the sine of angle A over lowercase a equals the sine of angle B over lowercase b equals the sine of angle C over lowercase c. To find those sides, we solve proportions. Now, proportions are two of those fractions that we see up there set equal to each other. And then how you solve proportions is just by cross multiplying. So we want to set this up so that we just have one piece of information that's missing, and then we can use cross multiplication to find it. But first, we have to figure out, can we use law of sines? And this one's going to help us out by flat out telling us, hey, we're going to give you an angle side congruence situation, even though you look at this and you say, well, there's not two triangles there. Why are we talking about congruence? You can use our law of sines when you see the information that you have meets that angle, angle, side, angle, or sometimes the side, side angle situation. So let's check this one out. Solving a triangle given two angles and a side. Solve triangle ABC given that angle A is 36 degrees, angle B is 48 degrees, and little a, the side length, is 8. So I take a look at this and I'm trying to figure out in order, what do I have? And from left to right I see an angle, and a side. Those are the ones that have numbers, numerical values for them. So that gives me the angle, angle, side situation, which means I can use the law of sines. Now, the next thing I see is solving. Solving means we're going to find all three sides and all three angles. And the good news is they gave us some to start. So I start thinking about the law of sines and how I have to have an angle and a side opposite that to set up one fraction. Well, that would be this one right here. This is the angle, and this is the side opposite. So the sine of 36 degrees over 8 equals, and now I'd want to go after something that I can find because I want to have one piece of information that's missing. Not two, I need one. So I realize the other piece of information I have right here is that the angle for finding the sine of B is 48 degrees. Now, that's going to allow me to find the side opposite angle B, because now I have a proportion and I can cross multiply. So I will have B times the sine of 36 degrees equals 8 times the sine of 48 degrees. And then I would divide both sides by the sine of 36 degrees. And of course, I would show my perfect answer, just as we've always done in the past, my elegant answer. But then I do want to know what this is as a decimal. So I'd grab my calculator, and I'd make sure that I'm in degree mode, because all of this that we've done so far has been in degrees. And it's a good thing I checked, because this was in radians. All right, so we had 8 sine of 48 degrees. And then I'm going to divide that by the sine of 36 degrees. And you want to watch for the parentheses here. If you want to punch this all in at one time, I know it seems like a lot of parentheses, but we want to make sure that the calculator is going to follow the order of operations for this. So one set of parentheses for the numerator, and then there is only one piece of math being completed in the denominator, one term, so it will get it for you there. Let me quick check. If it follows the order of operations, which it will, it shouldn't have any trouble with us punching it in without those parentheses, and it doesn't. All right. So lots of different ways. I just try to be really careful as I'm punching these in, and I don't leave the order of operations to the calculator because I want to make sure that things are going to come out right. So our little b is 10.115. And then I would look around and see if we didn't have a label somewhere in all of that information. And it turns out we did not. We had no labels anywhere. So now I start thinking about, what do I have and what's left to find? And we just found little b here. And I realize, well, with a very little amount of math, we can figure out what c is. Because every triangle, the measure of angle c equals, is 180 degrees. So if we take 180 degrees minus 36 degrees minus 48 degrees, that will give us the measure of angle C. So 180 minus 36 minus 48 leaves us with 96 degrees for angle C. So I started thinking about my proportion that would help me figure out what little c, the side length c, is. And I realized, well, I'm just going to go right back to the one they gave me with an angle and the side opposite, which was the 36 degrees and the 8. And then I can use my sine of 96 degrees over little c, because I already have side B. I already know what the measure of angle C is, and I want to go back and use as much information as I can from what they gave me, just in case I made a mistake. So I'm using that sine of 36 degrees over 8 to make sure that nothing's going to go wrong here. And again, we'd cross multiply. So C times the sine of 36 degrees equals 8 times the sine of 96 degrees. Divide both sides by the sine of 36 degrees. Write it down in the elegant and perfect form. And then, and only then, do we punch it into the calculator. So 8 sine of 96 degrees. And we're going to divide that by the sine of 36 degrees. So 13.536. And then usually at this point I just stop, check for labels again, but then I take stock of, all right, what did I find here? Because I'd like to have all my answers in one spot. So I know the measure of angle C, that came out to 96 degrees. I know little b, that was 10.115, and there was no label in this problem. If you wanted to, you could put a lowercase u for units, but we don't require that. Little c is 13.536. Now, if there were a label and you didn't put it on, then yeah, you're going to miss, probably a part of a point, like a half a point for not putting a label on. But when they don't give you labels, you don't have to put a little u for units down there if you don't want to. But now this would make it very easy for somebody who's grading my paper to check my answers and go back and check my work. Just kind of trying to keep things organized as you go through those. So that's all I wanted to do for our Tuesday when we have ACTs, because we need to talk more about that ambiguous case, and I would rather have you in person for that. So that means you can complete those 4 problems right there. 1, 2, 5, and 8, using the law of sines. So again, don't forget that you should be checking to see, is this a situation that I have angle, angle, side, angle, angle? In fact, I'm not even going to have you do any of the side angles. I hope I didn't anyway, because what I want to do is cover that more completely with you before you go back to do any of that. So those 4 problems, that'll be it for ACT Tuesday.